Hey, what's up? Welcome back. Today we are going to talk about the difference between quenching, tempering, annealing, and normalizing. At the end, we are going to discuss stress relieving as well. So let's get it started. So first is quenching. So quenching means you heat up the steel into the austenitic temperature, and then you suddenly drop that red hot steel into cold media, such as water or oil. The purpose for quenching is for strengthening the material or hardening the material, and the result is to form martensite phase. So the quenching rate depends on the fluid media and also depends on the degree of agitation. So the fluid media could be water and oil, and water quenching are the most severe one. And also violent agitation can improve the quenching even further. That's about quenching. So the purpose of quenching is for improving the strength and the hardness of steel. As a result, we get martensite phase. However, martensite is not that always good. So the pros for martensite is it has higher strength and higher hardness. On the other hand, martensite are usually too brittle to use, and they are like glass until they are treated by a process called tempering. So tempering is a low temperature heat treatment that can improve toughness of the material without significantly reduce the hardness. And if we are applying tempering, the toughness of the material could be increased by a factor of 10, but the hardness of the material will only lose about 1 or 2 Rockwell C hardness. And the tempering process is usually an integral part of quenching hardening. And the tempering is usually done immediately right after the part is cool enough to touch but not stone cold. So this is tempering, which is a process right after quenching in order to reduce the brittleness of the material, or you could say to improve the toughness of the material. At the same time, it will not significantly reduce the hardness of the material. And the next process is annealing. So for quenching, it has a rapid cooling rate, which we suddenly drop the hot bright material into cold media. However, annealing is a process of slowly raising the temperature into the austenitic temperature range and also slowly cool the material, and in particular, let the material to be cooled in the furnace. And annealing is the process to be used only when something goes wrong. And like we just talked about, for annealing, we still have to heat up the material into austenitic temperature and let it cool down in furnace. So the application of annealing, so such as if the material is machined and hardened, but we realized that the dimension of the material was incorrect. So we could anneal the part and remachine the part and reharden the part. So annealing is more common to address the unexpected heat treating results, such as if the material is over-tempered and it won't meet the required hardness, then we could possibly anneal the material and reharden it. And also steel parts that are softened by annealing can be reworked or welded. So this is annealing. And normalizing is similar with annealing. And the only difference is instead of letting the material cooling down in furnace, we are going to let the material cool down in air. So normalizing is the process of heating the steel to austenitic temperature and let the material cool down in a room temperature or in air. So normalizing is usually used on hot worked material to make the properties and the alloy additives uniform in distribution, such as in casting. Usually, they are locally cooled at different rates. As a result, the alloy differences or the grain size differences vary everywhere of the part. And by doing normalizing, we can make both the alloy distribution and the grain size to be more uniform. And like we said, for normalizing, we still have to heat up the material into the austenitic temperature and let it cool down in the air. So hot rod bars are usually normalized, and also the mechanical properties of normalized steel are usually better than the properties of annealed ships because the air cooling has a faster cooling rate than furnace cooling, which means normalizing has a faster cooling rate than annealing. And faster cooling produces finer microstructures of the material and also higher hardness than annealing does. And the last one is stress relieving. So for complex machine parts, we usually need to have a stress relieving process to achieve dimensional stability. And it's usually the designer's responsibility to decide if stress relieving is needed or not. So most likely, whenever you need to do welding and machining, especially for machining the long, slender parts or the parts has close dimensional tolerances, we need to perform a stress relieving ahead. So for stress relieving temperature, it will not need to be in austenitic temperature. Otherwise, you will lose all the strength of the material. So usually, stress relieving temperature range is about 38 to 93 degrees C. And for carbon steel, it's usually 538 to 650 degrees C. And if they are alloy steels, the temperature is going to be even higher. Then for stress relieving temperature, as we said, as the temperature goes higher, then you will lose more strength. So as the designer will need to consider the trade-off between stress relieving temperature and the strength of the material itself. All right, this is the difference between quenching, tempering, annealing, and normalizing, as well as a little bit about stress relieving. Thanks for watching. We'll see you next time. Bye.